We're going to be talking about acid-base properties of salts today. One of the hardest concepts to try to understand is how a salt might act in solution. So, when we take sodium chloride, for example, and we put sodium chloride into water, we understand that the sodium breaks down to sodium ion, and then the chloride breaks down to Cl minus. Now, the big question we have here, do those two ions affect the pH of a solution? Keep in mind the pH ranges from 0 to 14, where 7 is neutral, 0 to 7 is acidic, and the 7 to 14 is basic. So how would NaCl affect the pH of a solution? Now, there's some information and some prior knowledge that you have to know before you can actually answer this question. The first thing is, let's make a couple rules here, all right? The first rule is that when you talk about alkali metals, all right, so alkali metals are found in group 1A. Any metals that are found in group 1A are going to be considered to be neutral. So when we look over here and we talk about sodium plus 1, well, sodium plus 1 is neutral because it's an alkali metal. Now, we go and look at the chlorine. We have to ask ourselves the question as to where does the chlorine come from? You're probably saying, what does that even mean? Well, chloride is the conjugate base of which acid? Right, if you said HCl, then you're correct. Chloride comes from HCl. Now the question now becomes, what type of acid is HCl? HCl is a strong acid. All right, so if HCl is a strong acid, that means that chloride is a conjugate base. It can't be itself strong because HCl is strong. So Cl minus is a weak conjugate base. Now, if a conjugate base or acid is weak, then it will have no effect on the pH of the solution. So, this goes back to talking about chloride being weak, therefore Cl minus itself is going to be neutral based off what we just said right here. It's going to have no effect. So when we come back and we talk about the compound NaCl, NaCl, since it has sodium ion which is neutral because of group 1, and then Cl minus is weak because it comes from strong acid, NaCl is going to be neutral. So it will not have an effect on the pH of the solution. Now, as we move forward, we need to make sure we understand which compounds are strong and which compounds are weak. There is a list of 8 strong acids, and then there's a list of 8 strong bases. You have to know what those strong acids and strong bases are in order to work this type of problem. So, just to give you a short list of acids, we saw one already, which is HCl. So these are strong acids. So HCl is one. Another strong acid would be HNO3. nitric acid. Another strong acid is H2SO4, which is sulfuric acid. These are common acids that are strong. Now, when we start talking about their conjugate bases, that makes the conjugate base weak. And anytime you have a weak conjugate acid or base, those ions themselves are considered to be neutral and will have no effect on the pH of the solution. Now, a short list of strong bases that you want to know. Well, this is where you're going to have a metal combined with a hydroxide ion. And so, sodium hydroxide would be a good example. Potassium hydroxide would be a good example. Calcium hydroxide would be another good example. So these are just three examples of strong bases, meaning that their conjugates are going to be weak. Therefore, they will have no effect on the pH of the solution. So this is just prior information that you have to know in order to be able to solve for this type of problem. Our end goal is to determine if a salt is going to act as an acid or a base. On our list, we're going to be talking about anions and how an anion affects the pH of a solution. Still goes back to what we were just talking about in respect to understanding whether you're dealing with a strong acid or a strong base. So let's talk about sodium acetate. Now, what's the formula for sodium acetate? We know the sodium part. What's acetate? If you said CH3, CO2, you're right. All right, CH3, CO2 is the formula for sodium acetate. Now, as we start to break it down, we're going to form sodium ions, and we're going to also form acetate ions in solution. Just like before, we're going to look at each of those ions and determine if it's going to be neutral, acidic, or basic, and that's what affects the pH of the solution. We already know what sodium is. Sodium is neutral. What about acetate? All right. Acetate stems from acetic acid. All right. So acetic acid formula is CH3CO2H. Acetic acid is a weak acid. And this breaks down to form acetate plus the hydrogen. We're not concerned with the hydrogen. We're concerned with this. So this is the conjugate base of acetic acid. Now we already know that acetic acid is weak. Well, that means the conjugate is going to be the opposite. So this is weak. That makes this strong. How does that affect the pH? It's going to make a difference. It's actually going to make the solution basic because acetate is the conjugate base. And so this ion is going to be basic. So as a whole, the solution that you dissolve the salt into will be basic because of the acetate ion. Like we talked about earlier, we have to pay attention to the anion or the cation. In this case, we're talking about the anion specifically. You have to pay attention to the anion and how that's going to affect the overall pH of the solution. That stems back to where it's derived from. So let's look at another example. Let's say we have calcium carbonate. All right. Calcium carbonate has a formula of CaCO3. It breaks down to form calcium ions plus carbonate ions in solution. Now, so calcium ions themselves are neutral. They're sort of like the alkali metals in that sense. And so they're going to be neutral So we don't worry about the calcium in this case. What we're focused on is the carbonate. Now, where does carbonate come from? Carbonate, CO3 minus, comes from bicarbonate or carbonic acid, either one. So in this case, we just go back to carbonic acid. So this kind of helps us to determine what type of compound carbonate is. So carbonic acid will form an equilibrium. And I'm not going to show the equilibrium in this case because it's a little bit more involved. But carbonic acid is a weak acid, and carbonate is going to be the conjugate base of this weak acid. So if this is the conjugate base of a weak acid, that means that the carbonate is strong by nature. And so how does that affect the pH of solution? Well, since it's a conjugate base, it's going to cause the solution to become basic. So calcium carbonate is a basic salt. And that's an important thing for nature too, because our bones are composed of calcium carbonate, our teeth are composed of calcium carbonate. And we all know that if you drink too much soft drink, or if you drink too much acid in general, it doesn't have to be soft drink, it could be orange juice, grape juice, lemon juice. All those chemicals are acidic, and they will break your teeth down. They will cause cavities in your teeth over time if you don't wash your mouth out. But because, as we've learned in our first chemistry course, acids do what with bases? They neutralize each other. So since calcium carbonate is a basic compound, if you put an acidic solution in your mouth, what you're going to eventually do is you're going to neutralize your teeth. You're going to dissolve your teeth. So keep that in mind. Always wash your mouth out. Now, so these are just a couple examples of an anion. Now, let's talk about if we have a cation. Now, there's not many examples that we work with cations, but there's one specifically, one polyatomic ion that is a cation. Now, remember, anions are negatively charged, and cations are what? If you said positive charge, you're right. So there's one ion, which is ammonium. So let's say we have ammonium chloride, for example, here. All right. So ammonium is your cation, and then chloride is your anion. These form NH4 plus CO minus. Now we've learned earlier in this video that CO minus is a neutral ion. So let's focus on this one here. So where does ammonium come from? Ammonium comes from ammonia, which is NH3. So what is ammonia? Ammonia, if you look at the table in your appendix in your book, and if you look at any table, I'm gonna put a picture of this on the video right now. So find the picture in the video and find ammonia. Ammonia is a weak base. And so you come back over here and say, okay, well, what is ammonium then? Ammonium is the conjugate acid. And since it's the conjugate acid of a weak base, that means that this conjugate is strong by nature. So that's going to determine what type of salt ammonium chloride is. So in this case, since this is the conjugate acid, which is strong, that means that this compound is acidic by nature because of the ammonium ion present. Now, since that's the only polyatomic ion that is a cation, we have to focus on other metals. Now, we've already talked about group 1A and group 2A not being necessarily affecting the pH too much. But we haven't talked about the transition metals and group 3A. So let's talk about transition metals just for a second here. So highly charged transition metals can act as acids in solution. So get an example of a high charged ion is Fe plus 3 or aluminum plus 3 or sometimes nickel, right? Nickel that has a plus 2 charge. So these compounds, anytime you have these metal ions in a compound, they are going to cause that compound to be partially acidic, or in some cases acidic. So if we take, for example, iron 3 chloride, FeCl3, so this would be iron 3 chloride. We break this down and it'll form iron plus 3 chlorides. Now we've already talked about chloride being neutral, so that's not going to have any factor in affecting the pH of the solution. We're focused on the iron plus 3. Well, based off the rule that we just talked about here in this box, iron plus 3 is going to be acidic. All right, and so that being the case, that makes FeCl3 acidic by nature. So it's an acidic salt. A lot of times you're going to have iron in your ground. If you ever have to grow a garden, or if you want to grow a garden, one of the things we always have to do is we have to put fertilizer in the ground. Now in North Carolina specifically, we have a lot of iron in our rust. If you look at the ground, it's usually red to orange color because of the iron. Well, iron plus 3 is a part of that structure, which causes the solution, the ground, to be acidic. And so when you try to grow tomatoes or cucumbers, which require a more basic solution, or basic soil in this case, you oftentimes have to put in fertilizer to help bring the pH of the soil up. And so this is an important characteristic of what's in our soil. Now, we talk about aluminum. Right? Aluminum is another ion that's acidic by nature, and aluminum is actually found in various minerals throughout our soil. And so if you happen to put a chemical into the soil and you dissolve this aluminum out of that mineral, that will turn the ground acidic, and in turn could potentially harm the crops or the trees or plants that are around it, because aluminum itself is poisonous to plants. So I hope this helps you guys in understanding a little bit more about whether salts will affect the pH of a solution. So if you have any questions, post them in the comments. I'll be glad to answer them for you. Thanks.